Welcome back everyone. We're going to take a look at paragraph 8.2, which is about volumes of pyramids. That's going to be theory A, and theory B is going to be about the volume of so-called cones. And to start off, what are pyramids exactly? Well, most of you, if I say what are pyramids, you immediately think about pyramids like this, right? Which actually look a bit more like this. They are not freestanding in the desert, you could say. They're very close to the city. And there are some other more modern approaches in architecture to triangles as well, or to pyramids, sorry. This is the pyramid entrance at the Louvre in Paris, for example. This is in Las Vegas. What do you think that houses this big pyramid here? Certainly not a tomb, right, like in ancient Egypt. It's just going to be a casino and a hotel. Okay, so form here is, we think of ancient Egypt when we think of pyramids. So this casino is in the style of Egypt, so we build it in the form of a pyramid. Or, for example, this pyramid is also in an American city. You cannot guess what the function of this building is if you just see the form. Mostly when architects design something, we want form and function to kind of be interconnected. Here you can guess 10 times, but most of you will not guess that this is a basketball field inside. Okay? That being some practical examples of pyramids in real life. Now the mathematical theories behind it. How can we, for example, calculate the volume of such a form? First of all, pyramids always have an apex on top, and that apex is connected with edges to its base. The base, again, doesn't always have to be on the ground. You see, sometimes if we tilt the pyramid, then in this case the base is not on the ground. The height is always going to be the distance from the apex to the base. And it's always going to be the shortest distance, which means that it's going to be the height that's perpendicular on the base to the apex. Right? So here, for example, you cannot see it because the depth perception is quite difficult in a flat surface. Sometimes your height can be a lateral edge, but then that means this vertex right here is directly underneath my apex. Here it's not the case, right? It's going to be in the middle of those pyramids. And here the base is a rectangle, but your base can be a triangle as well. It can be a prism. For example, what could it be? Almost all forms. If it's going to be a circle though, you have a cone, so don't use a circle. But most examples that we will see in this book will either have a rectangle, a triangle, or a quadrilateral, and maybe some other kinds of polygons as well. The volume of a pyramid, and again, previous theory was about a prism. Know those theories, right? When you're on the test and you do not know the formula, then it's going to be very difficult to calculate the volume as well. Here, the volume of a pyramid is going to be 1/3 of 1/3 times the area of the base times the height. So it's almost the same as the volume of a prism, only now we have 1/3 in front. 1/3 times area of the base times the height. So for example, how can that work in a question like this? And again, start by sketching the base. If you have a question like this, the first step that you're doing is sketching the base. You can score points on that, so you're going to do that. Okay? It shows me that you understand what the base is. It shows me that you're able to correctly investigate how this base is formed on ADHA, and it makes you a lot more easy for yourself to fill in the dimensions and find what you have to calculate. Oh, and I think in pyramids, finding the base is a lot easier than with prisms, right? Because you just have one apex and all the edges that are connected to the apex then connect to your base. So here, GQ, GH, GR, GD, that are going to be the outlining of my base. So in this case, R, D, H, Q, or QR, DH, so as they call it. So this is your sketch, and this looks a lot like paragraph 8.1, right? Calculate the base. This is a strange form, so I suggest that you calculate the area of the rectangle, ADHE, and then subtract the triangles. Do you still know the formula for calculating the area of a triangle? I hope you do, because you're going to use it a lot during this chapter. It's going to be a half times the base times the matching height, right? Or a half times the side times the matching height, depending on which version of numbers of space, which version number you use. Sometimes you call it the base, sometimes you call it the side. So a half times 1 times 3, or a half times 3 times 1 is the same. And here a half times 1 times 3 as well. So they do area of the whole rectangle, 4 times 3, minus this one, minus this one, gives me 12 minus 1.5. Minus 1.5 is 9. Now what's going to be the volume of my pyramid? It's going to be 1/3 times the height of the pyramid, which is going to be GH, right? Because that is the shortest distance. That line is perpendicular on my base. Luckily that height is given in that case. So it's going to be 1/3 times the area of the base times the height is a half times 9, we calculated that, times 6 gives me 18 cubic centimeters. Again, don't forget the units. If you do an exercise like this, first find the base, then sketch the base, investigate how I can calculate this base, write then how you do that, find the height of the pyramid, and then calculate the volume. Those are all steps that you will be graded on. So right now we know those 3 more specific 3D shapes. We now know how to calculate the volume of those. This one is in the prior knowledge. It's going to be pi r squared times height, right? The area of the base times the height. Here the area of the base times the height. Again, only here my base is going to be always a circle, otherwise I don't have a cylinder. That's why I use PR squared, right? Because that's the area formula for a circle. And the last one that we've just taken a look at, the volume of a pyramid is 1/3 times the area of the base times its height. So you see that the area of the base times its height comes back multiple times. Only sometimes you add something to the formula, and sometimes you know that the area of the base is always a circle, so you change that part to PR squared. Okay? Good luck. In the next video we're going to take a look at how we can calculate the volume of a cone. See you then.